Hello everyone, welcome to Inspecialist Training channel. I'm Omar Farouk and today we are going to talk about the mechanical properties of the materials. So let's start. Welcome again. The mechanical properties of a material are those properties that involve a reaction to an applied load. Mechanical properties are used to determine how a material would behave in a given application and are helpful during the material selection. Before talking specifically about the types of mechanical properties, let's talk about the loads and what is the stress-strain curve. Number one is, what are the types of forces and loadings? The application of a force to an object is known as loading. Materials can be subjected to many different loading scenarios, and the material's performance is dependent on the loading conditions. There are five fundamental loading conditions: tension, compression, bending, shear, and torsion. Tension is a type of loading in which the two sections of material on either side of plane tend to be pulled apart or elongated. Compression is the reverse of tensile loading and involves pressing the material together. Bending loading involves applying a load in a manner that causes a material to curve and result in compressing the material on one side and stretching it on the other. Shear involves applying a load parallel to a plane which causes the material on one side of the plane to want to slide across the material on the other side of the plane. Torsion is the application of a force that causes a twisting in a material. There is an important note. If a material is subjected to a constant force, it's called static loading. If the loading of the material is not constant but instead fluctuates, it's called dynamic or cyclic loading. The way a material is loaded greatly affects its mechanical properties and largely determines how or if a component will fail, and whether it will show warning signs before failure actually occurs. Number two is, what is the stress-strain curve? Firstly, the term stress is used to express the loading in terms of force applied to a certain cross-section area of an object. From the perspective of loading, stress is the applied force or system of forces that tends to deform a body. For example, a bar loaded in pure tension will essentially have a uniform tensile stress distribution. The stress in an axially loaded bar is simply equal to the applied force divided by the bar's cross-section area. The stress can be measured by Newton by meter square. Secondly, the strain. The strain is the response of a system to applied stress. When a material is loaded with a force, it produces a stress, which then causes material to deform. Engineering strain is defined as the amount of deformation in the direction of the applied force divided by the initial length of the material. This results in a unitless number. For example, the strain in a bar that is being stretched in tension is the amount of elongation or change in length divided by its original length. Number two is the stress-strain curve. The stress-strain curve relates the applied stress to the resulting strain, and each material has its unique stress-strain curve. A typical engineering stress-strain curve is shown. If the true stress based on the actual cross-sectional area of the specimen is used, it's found that the stress-strain curve increases continuously up to fracture. As can be seen in the figure, the stress and strain initially increase with a linear relationship. This is the linear elastic zone, and it indicates that when the stress is applied, the material will return to its original shape. The plastic zone indicates that when stress increasing, the material will permanently deform. The slope of the line in elastic zone, where stress is proportional to strain, is called the modulus of elasticity, or Young's modulus of a metal in the elastic range. The degree to which a metal will deflect when a given load is imposed on a given shape. E defines the properties of a material as it undergoes stress, deforms, and then returns to its original shape after the stress is removed. Yield strength refers to an indication of a maximum stress that can be developed in a material without causing plastic deformation. Ultimate tensile strength, UTS, is the maximum stress that a material can withstand before fracture. Now let's talk about the types of mechanical properties. Number one is the ductility. The ductility of a material is a measure of the extent to which a material will deform before fracturing. The amount of ductility is an important factor when considering forming operation such as rolling and extrusion. Number two is the brittleness. Brittleness describes the property of a material that fractures when subjected to stress but has a little tendency to deform before rupture. At this curve, you can see the difference between the ductile and the brittle fracture. Number three is the toughness. The toughness is the ability of a material to absorb energy before fracture. Number four is the hardness. The hardness is the ability of a material to withstand localized permanent deformation by indentation. Hardness may also be used to describe materials' resistance to deformation. Number five is the resilience. The resilience is the elastic energy that a material can absorb and release once the load is removed. So, in the image, the medium carbon steel having a higher yield stress has a higher resilience than the mild steel. Number six is the stiffness. Stiffness is the tendency of a material to react with a small deformation when the material is stressed. This property depends directly on the bond type between the atoms. The stronger the bond, the higher the stiffness. Number seven is the malleability. The malleability is the ability to deform under compressive stress, which can be easily formed by hammering or rolling. Number eight is the hardenability. The hardenability is a term used to describe a material's ability to be hardened when it's exposed to heat and then quenched or cooled rapidly. Thank you everyone for watching, and don't forget to subscribe and activate the alarm button to see the next videos.